Hey you guys, this is Mr. Sal. We're going to look at sequencing rotations. Thanks for watching. Don't forget to like, comment, and subscribe. Take a minute and copy these objectives down on the worksheet. We'll read them here in a minute. I know that sequences of rotations keep lengths and segments and angles the same. This is just saying it's a rigid motion. It's not going to change any of those. Rotations, right? I can describe, this isn't supposed to be there. I can describe rigid motions that would map a triangle back to its original position after being rotated around two different centers. Yes, we could, and we will. Now notice with those last two lessons, the first one was translations, the next one was translations and reflections. Now we're looking strictly at rotations, like a double rotation kind of thing. Again, we're not looking at triple or quadruple primes, so we're really just looking at two different transformations, which is part of your logo project. You guys got to be able to make two transformations in order to create your own logo, and it should look pretty. All right, we are going to rotate triangle ABC, D degrees around center D, and we'll label the rotated image A prime, B prime, C prime. Take a moment and try to do that with your partner. Just rotate it around center D for now. This did not specify how many degrees to rotate it, so you get to choose how far to rotate. So just like you guys would do with the scratch piece of paper, I'm going to trace this. All right, let's see if we can rotate this thing. You guys want me to rotate in the positive or negative direction?
Positive.
All right, positives have it. Positive is counterclockwise. Now again, the idea, and this is kind of difficult on the iPad here, but I'm going to try to keep that center of rotation on the center right there. So let's see if this will work. Trying to keep it on the center. You guys tell me when to stop.
Stop. Why is that negative? You said you were going to
Oh yeah, sorry. So I'm going to counter. Thank you. That's good. Counterclockwise. It's better. Okay, say when to stop.
Stop.
Oh, okay, that's good.
No, I was waiting. Don't stop.
No, actually, my hand won't turn anymore. So that's good. That's a good place to stop. Let's label this A prime, B prime, C prime. And that's all we wanted you to do. If you rotated it more or in the other direction, that's okay. But we were rotating around the center D specifically. All right, now we're going to take that triangle and rotate it around the center E. Now again, you get to choose how many degrees you want to rotate it. We did that one in the negative direction, so we'll plan on doing this one in the positive direction. No, negative. We rotated that in the negative direction, so we're going to plan on rotating it in the positive direction. So yeah, again, just like you guys are doing, I'm going to trace this the best I can, something like this. And I'm rotating it around the center E. All right, let's see if this works a little bit better this time. So you guys tell me. Oh, hold on a second. All right, here we go. Try seeing if I can rotate this thing. There we go. All right, you guys tell me. Stop right there. That sounds good. That's a good place. All right, let's label these as A double prime, B double prime, C double prime. And that's all we wanted on 1B right here. All right. Now we're not so worried about measuring these or either the lengths or the angles because a rotation is a rigid motion, so we know that these should be the same length one way or the other. How can you explain what you observed in part C? So how do we know that they're the same lengths and angles? What statements can you make about properties of sequences of rotations as relate to a single rotation? Well, we already knew that a single rotation is rigid motion, so if we do it twice or 3 or 4 times or more, it's going to keep things the same, angles and lengths. So it's not going to change the length or the size of anything. Alright, so we're rotating this around D counterclockwise. Let's see if it'll let me do it. There we go. Alright, you guys tell me. Oh, I'm going clockwise, I apologize. Counterclockwise, you guys tell me when to stop.
Stop.
Stop. There we go. All right, so let's label these then. All right, label the image A prime, B prime. We did that. So that is 2A. All right, so let's rotate this around point E then. So point E is right here. All right, which way do you guys want this rotated? Positive or negative? All right, I heard negative, which is in the positive direction, so let's do that. All right, let's see if this will work. Oh, messed up. All right, here we go. You guys tell me when to stop. Trying to keep that center on the center of rotation. I ran out of space, so I'm going to stop there. Sounds good. All right, so let's label these points then. So yeah, we got double prime marks on this one because it's a second transformation on this, which we've done, and that looks very nice. We're going to use what we have drawn here as to answer the next few questions on 2. Now the thing about that, what they wanted us to do in the original was to label this second image just as A prime, and then this one will be C prime, and then this one is B prime right there. So the reason why we did that is because they told us just to label it this way. We're going to have to keep that in mind as we look at the other problems so that we can answer them correctly. Can a single rotation around center D map the triangle A prime, B prime, C prime onto the triangle ABC? So on this one, we are looking at the purple triangle on this. So just take a moment with your partner and discuss this and write a sentence about if it can or not. The answer is that you could not, because it was double rotated around 2 different centers, so I couldn't use one of those centers to rotate it back into the original pre-image. Okay. One other thing we may notice on this is that A prime is a different distance away from the center of rotation than A is, which means they have different radii. So it wouldn't be able to even get close to that point if we rotated it back over there. So take a moment with your partner. Can a single rotation around the center E, so that's the purple point, map our purple triangle back onto triangle ABC? All right, this one is no for the same reason as that last one. A prime in the purple there is a different distance away from E, and we could check that. This distance is a different distance from this one, which means it doesn't matter how far I rotate it, or if I were to bring these 2 lines together, A prime looks like it's closer, maybe about right there. So I couldn't get them to line up. We need to find a center of rotation that would take this purple triangle back to its pre-image. So again, we're ignoring this red one. Let's get rid of it. Now this idea of finding a new center of rotation, or finding the actual center of rotation of some kind of transformation like this for rotations, is new. So we don't expect you guys to be able to know how to do that, even though you could do it. Okay, so as it turns out, yes, we could find a center that would map triangle A prime, B prime, C prime back to its pre-image ABC. Here's how this works. So the first thing we got to do is connect all of the image points with their pre-image points, like this and this. Okay? In fact, I'm going to ignore that last one because I don't really need it. So I only need to do this with 2 of them, even though you could do it with all 3 just to make a confirmation on this. Now what I'm going to do is I'm going to take those green lines that I used to connect the points that correspond with each other from the pre-image to the image. And I've got to find the halfway point on these, which to me looks like this one's right about there, and this one's right about right there. Okay?
Oh,
So,
no way.
I connected them, I find the halfway point. Then I've got to draw a line that's perpendicular to the green one, which for me is going to be, I don't want to do it like that. Alright, now the reason I don't need that third line, even though I could use it to confirm this, but that point right there would be the center of rotation to get this purple triangle back onto that original pre-image. Let's see, again, that's freehand, so it's not going to be perfect, but let's see if we can get that to work. Alright, let's see if we can get this to work.
Whoa.
There it is. Sorry, I kind of drifted off. Actually, that worked out pretty good. So I've taken this triangle, the purple one, and I rotated it with this blue one around that center. It wanted us to label it F. Thank you. F. Rotate triangle ABC 90 degrees counterclockwise around center D first. Then we're going to rotate the image another 90 degrees counterclockwise around center E. Make sure you label the triangle A prime, B prime, C prime. That's after the second rotation. Take a moment and do that with your partner. Alright, so I'm doing the same thing you guys should be doing, with, especially with that scratch paper, is I'm going to trace the triangle, and then I'm going to rotate it 90 degrees counterclockwise around the point D first. Alright, let's see if we can make this work. 90 degrees counterclockwise. This is in the positive direction. So, that's not going to work right there. Hold on a second. Let's see if we can try again. There. Oh, no. Oh, still doing the same thing? No, the pen won't work. Alright, so I'm going to rotate this 90 degrees. There we go. That's better. Let's see if I can get it to stay though. Alright, now it wants us to rotate this around the center E. And this is 90 degrees clockwise again. So if I did that, 90 degrees, about right there. Alright, the next thing we need to do is label this with the points A prime, B prime, C prime. So there we go. This is the double rotation on that. Alright, now if we had done this exactly, we would have gotten something like this. But again, if we're close because we're doing this freehand, that's okay for now. But this would have been an exact rotation for these. Now what we're going to do is we're going to take triangle ABC, that's the original pre-image, and we're going to rotate it around E clockwise, 90 degrees. And then we're going to rotate that another 90 degrees counterclockwise around the center D though. And we'll label that new image A double prime, B double prime, C double prime. Take a minute and do that with your partner. So again, I'm just going to trace this ABC triangle. And this one says we're going to rotate it 90 degrees clockwise, or counterclockwise around the point E first. So let's see if we can get that just to do it. Alright, here we go. So we're going to rotate this one 90 degrees. We're just trying to keep that center rotation where it's supposed to be. Right there. And, well, that looks like about 90 degrees counterclockwise right there. Alright, after that, and this is what it wants us to do next, is to rotate this same triangle. So I'm going to trace it again, but I'm going to rotate it around D this time. Alright, so let's see if we can rotate this. Again, we're just rotating it approximately 90 degrees in the counterclockwise direction. So, oops, that's the wrong one. Let's see there we go. So we're going to rotate this 90 degrees, counterclockwise, around that point D. Looks like it's getting smaller. Alright, so that would be over here. Technology is supposed to work really good sometimes. Alright, and then we get, I don't know, something like this, I guess. Alright, and that is about 90 degrees counterclockwise. We'll label this. This is A prime right here, C prime here,
But it's prime,
and
right?
B prime there. Now, oh, it did want us to do this. Thank you. This one is double prime for these. Thank you. Alright, so we're going to compare these. A prime, B prime, C prime to A double prime, B double prime, C double prime. Again, if it was maybe a little bit more accurate, it would look like this. So there's some questions we need to answer about these. What do you notice about the locations of triangle A prime, B prime, C prime, and A double prime, B double prime, C double prime? What does the order, we want you to answer both of these questions. Does the order in which you rotate a figure around different centers have an impact on the final location of the figure's image? Take a couple minutes, talk about that with your partner, and write a sentence about these two questions. So that first part, what do we notice about the locations? They're different. Now, we need to keep in mind, though, is that we did the same exact rotations, but we changed the order. That's that second part. We changed the order of the different centers, which is why these changed locations on these. This is what the book said. We're going to rotate triangle ABC 90 degrees counterclockwise around center D. And then rotate the image another 45 degrees counterclockwise around center D. And we're going to label that image triangle A prime, B prime, C prime. Take a couple minutes to do that with your partner. Alright, so 90 degrees counterclockwise is going to move us about right here. And then we're going to rotate that another 45 degrees around the same center, though, which gives us this point right there. So we got, I don't know, something like that right there. So, well, that didn't work either. So we'll go ahead and label this then. This is C prime. And A prime is right here. And this is B prime. So again, looking at what the book had, we were pretty close to that. That's really nice. But now what we're going to do is we're going to rotate triangle ABC 45 degrees counterclockwise around center D. And then rotate the image another 90 degrees counterclockwise around center D. And we'll label this one, though, A double prime, B double prime, C double prime. All right, let's go and rotate this 45 degrees counterclockwise. I got about right there. But I'm going to rotate that another 90 degrees counterclockwise, which would be right here. Now, we may notice, or we should notice, that this is actually in the same spot as the other rotation that we had. So the question becomes, why is this one the same, whereas the other one that we did before was different? The triangles are in the same location this time, which indicates that if we're looking at the same center of rotation and we do the same rotations, no matter how many times we do it or which order, it will always end up in the same spot. All right, now number 5, triangle ABC has been rotated around 2 different centers, and its image is triangle A prime, B prime, C prime. Describe a sequence of rigid motions that would map triangle ABC onto A prime, B prime, C prime. That's a good one. Take a moment to do this one with your partner. Make sure you write a good full sentence, at least one, on the sequence that you would use to take triangle ABC to triangle A prime, B prime, C prime. Alright, so to do this one, I'm going to take triangle ABC and trace it. So there I got triangle ABC. So what I'm going to do is I'm going to take that and I'm going to flip it. Right there. Now if you guys like it, I can show that I flipped it along B. And that was just a vertical flip right there. Well, now if I took this thing and moved it over here, it's kind of close. If I put the A values on top of each other at this point, all I got to do is rotate it. Alright, so I'm going to rotate it. There we go. Well, that's okay. So what did I do? Well, the first thing I did is I reflected it. The second thing that I did, and again you may have done something different, but this is what I did. Number 2, I translated it onto the other figure as close as I could. I made it so A and A prime were on top of each other. And then after that, number 3, all I did is I rotated it just a little bit. And I rotated it counterclockwise. That's better. Of course, this is what the book had. They translated it, then they rotated it. Oh, that works too. Either way works.